Hello, everybody. Hello, everybody. Welcome back. Thanks for coming back. Thanks to the folks up in the balcony. So we're just going to get started with the next talk. We've got Axel and Patrick from the BMW group. They're going to talk about building self-driving cars with Bazel.
Thanks, Joe. Hi, everybody. I'm Axel. This is Patrick. We will show you how we use Bazel to build self-driving cars. So I'm Axel. I started at BMW as a software engineer. By now, I mostly take care about our CI system, so making sure that all our developers get their feedback as fast as possible.
Yeah, so my name is Patrick. I'm currently in the role of a lead release engineer at BMW, especially in this project. I have some experience with various build tools and a long history of building software for embedded systems. Started with some small embedded systems where you can easily overlook the whole source code, up to infotainment systems, which is nowadays more or less a Linux distribution, and up to now a cluster of multiple embedded systems from one source tree.
So our department is working on every driver assistance related feature that we offer. That is the beeping sounds you hear when you park your car up to fully autonomous driving in cities. For BMW, that's quite an advanced and big software project, and we are trying to use state-of-the-art tools wherever possible. Also one of the reasons we're here. It hasn't always been that way. Just 4 years ago, roughly, our software was split into 200 different software components. All of them were in different repositories. And for most of those, you didn't have the access rights. So you couldn't even see what your fellow coworkers were doing. We also had to set up 2 different build tool chains because we didn't trust either one of them. And just to make sure that we don't fuck up and you don't die when you drive our cars, we had 2. Also, the feedback was very delayed, so it took a lot of time for the developers to know if they introduced a new bug or not. Tool-wise, at that time, we mostly used MATLAB and C. The developers used Windows as their host system, so for their development machine. Build tools were CMake and sconce, and for the CI, we set up a Jenkins. And in the last 3 to 4 years, we grew a lot, like a lot. But now we have more than 23 million lines of source code. Close to 2,000 developers are working on that software stack, and that results in more than 20,000 CI builds per day. We mostly code in C++ and Python these days, but you will find all sorts of programming languages in our software stack. Host system, we nowadays use mostly Linux, but for some corner cases, Windows is still needed, even on the CI. The software is not actually deployed to then either Linux or Windows and then shipped to the customer, but to a very special hardware with a special operating system, which is then built into the cars at the factory. And this hardware is using a completely different architecture, several ones, AMD 64, MIPS, and this is then what the actual customer is getting. We also set up a new CI system. It's now hosted on our on-premise cloud. We will talk about the CI system in a bit. It's not just the scale that grew a lot. It's also, well, the complexity of the feature that changed a lot. Autonomous driving became a thing, and we started also working on that a couple of years ago at large scale. And with these advanced features, you need advanced tools, advanced simulators. Which is a huge challenge for your CI system. And at the same time, we adopted a very agile way of working. So our teams would now usually modify several software components at once, which is even further stress for your CI system because now you need to run multiple test suites for the average code change. All of those things combined, the growth of our developer, the growth of the source code, of the tools, and of this new working way, pretty much broke our old build system. We had really huge issues with feedback time and stability. So we started to look for alternatives, and that's when Patrick came across Bazel.
Yeah, so we looked around back then when we changed the way we are working, when we changed the code that we are developing. Also, we took the opportunity to look at our tool landscape. to basically see what kind of tool could fit our new requirements. And our requirements are not anymore derived only from the languages that we use in our code base, but also from the safety point of view. So we actually need to find a build system that satisfies all the safety requirements. 2 years ago, I went to the Bazel conference here at the same place actually, and there were some Lego bricks. And yeah, that was the reason why we picked Bazel in the end. Right? Okay, the official version sounds a bit different. We looked into various tools, BugPan, CMake, Make, Sconce, you name it, right? But from the past experience, we figured out that there are some features which are really crucial to build the software in the right way. One feature is, of course, the sandbox feature. So we need to ensure that we include and link the correct files into our build so that we do not take just another file which is named the same way but in a different tree for a different purpose, that we take this one instead. So sandboxing gives us the opportunity to, as long as you have your dependencies clearly defined, to also only put the stuff that you have defined in your sandbox and use it during your build. Next thing is incremental builds. So if your code base is growing, we also need a tool that supports you in making incremental builds. And the benefit on the plus side is also we can also incremental test now. That increased the velocity of our developers a lot. And I've written it on the slide, so only rumors say there's a Bazel clean. Unfortunately, our developers got used to the way of working like, oh, it doesn't work, let's make clean, try it again. Damn it, it still fails. Of course it does, because you have an issue there in your rule, you have an issue there in your build file, you have an issue there in your code. It's not anymore related to the build tool or some weird configuration. It took us a while, but nowadays it's pretty well accepted that the people don't clean anymore their workspace. Except for developers of rules, of course, so they still need to do it regularly. Therefore, we use the output user root flag on the command line to just point temporarily to another place where we can basically run our build and test the rules. Last thing, the dependency management. Last thing on the slide, sorry. The dependency management. In terms of ISO, where we derive our safety requirements from the ISO 26262, there are certain things described in there to not make mistakes others did already. So this morning we saw this nice picture, one of the first pictures where you see what you shouldn't do with a motor, basically. People have written down some requirements into specifications which ended up in the ISO 26262. One thing is dependency management. You need to have a clear process for your dependencies. And we figured out that you can establish additional processes, you can put into additional tools to manage your dependencies, but it becomes much easier if your build system as such already maintains your dependencies. And you treat them as code in your source tree. And it means any change that you make on your dependencies can be easily gated as well. They can be reviewed as well. You can make change requests or pull requests for them, basically. On the next slide, we see first the hermetic builds. That's kind of crucial. So we can easily say that our build is not anymore impacted by the host environment. This kind of works for me thing, right? It's not happening anymore. Not that often. It reduces simply the fact how your environment could influence your build. And that comes to the next point, reproducible builds. So Bazel has the focus on making your build reproducible. But just because Bazel tries to do that, it doesn't mean it actually happens or it's there by definition. Of course, you have additional tools in your Bazel build which still could produce non-hermetic, non-reproducible outputs. But with Bazel, it becomes more obvious when this is happening. And having the reproducible builds also allows you to validate changes on your host environment against a previous build. So we can, again, safety case, we can detect if the environment has an impact on our build results. So we can validate the results that we built on the cloud, as well as the results we validate on a bare metal host. We can see that there is no difference. So we can see that we can trust our CI system, which is running thousands of builds in the cloud environment. And query. So I initially mentioned that I started with some small embedded systems where we can easily overlook the code. That's not possible anymore. And we need tool support for looking what is going on during the build. So why are things happening? And the query part is really helpful for doing so. So thanks a lot. It also helps us to set up some tests. There's a gen query rule, basically, that you can use to query the dependencies of a certain target, and you can easily detect architectural violations with this rule. So you can see what kind of dependencies are pulled in. You can create whitelists for it, that you do not pull in dependencies which are originally meant for a different target, actually. All in all, we figured out we can kind of achieve the same with other build tools as well, but only if we add a bunch of other tools around it, and if we build up a massive tool landscape to achieve the same goals. And that, in the end, would also be hard to maintain. It would be hard to review. It would be hard in terms of safety to see how do they interact with each other, actually. So it becomes quite handy that there's a tool that provides all this in one place, and we just need to review this tool, actually. So how did we migrate?
Yeah. So I know that Patrick convinced us few CI engineers that Bazel is a cool thing. The question came up, how do we pull this off? I mean, you saw it before, 23 million lines of source code. Well, back then it was a little less, but still. We are talking about huge efforts here to migrate your existing software stack to a completely different build tool. And all this while being deployable this whole time. So you cannot just stop everything, migrate, and continue 2 months later. Every product manager would just kill you. So we came up with a plan, and the plan kind of worked out well for us, and that's why I would like to share it with you and might help you as well. What you see here is the time axis and the usage of our CI systems. You see in red the CMake system, which kept on running in the background all the time, and then at some point was shut down. And you see the Bazel system, which first slowly and then very rapidly was able to build our software stack. And at the end, it's the only tool we have left. The way we did it was we first approached our management and said, hey, we have this new tool here, and we think this tool might help us to solve some of those issues we're having. Please give us a team of 5 to 6 people to look into this a bit more deeply. They gave us the team. We started the next day. What we did was writing down all the use cases that the CMake CI system was fulfilling. And then we picked on purpose the most hardest ones that or where you have the hardest time to do it in Bazel. For us, that was the integration of our simulation middleware, something we will talk about later as well. Why did we pick the hardest stuff at the beginning? Because we wanted to find potential blockers as fast as possible. 3 months in, actually way longer than we thought it would take, we didn't find any blockers so far. And we actually reached a point where we said, well, the remaining 90% of our workspace can be pretty much migrated by copying what we already did for the first 10%. So this gave us a pretty good feeling, and we approached our management again and said, hey, I think we figured it out. This will actually work. Let's roll it out. And so we did, and for roughly a month, almost every other developer of our department worked on baselizing our source code. Initially, we thought this might take 1 or 2 weeks. It took a month. What they basically did is writing build files wherever there used to be a CMake file. For sure, we didn't find some things that turned out to be way more complicated than we thought they would be. So this delayed the whole thing a bit further. But at some point, we got it. The final test drive on the road was done. You could even drive the car using Bazel. And at that point, we switched off the CMake CI system. Why does this approach works kind of well? First of all, it's easy to sell to your management because you don't ask for a full Bazel migration at the beginning. You ask for a small team to investigate if there are any blockers. And only if you can technically prove that you're very likely to pull off the whole thing, you then go for the final decision. This is really easy to sell. And it's safe to sell, also for you. And the other benefit is that you will only need for a very short period of time a lot of manpower. This is the rollout phase. And at that point of time, when a lot of your developers will come in contact with Bazel for the first time, you will already have a team of Bazel experts in your company that work with Bazel in depth for a couple of months, which is a pretty good learning resource for every other developer in your company. OK, so how is Bazel working out for us now? Actually, quite well. When it comes to execution times for example, unit tests, we were able to achieve a 10 times speed improvement using remote caching. For the build for the final target, so the hardware that is then put into the car, we are even able to speed it up by around about 12 times. The cool thing here is that in order to build for the target, you need some really weird tools like code generators or the operating system, which is then running on this ECU, which is built into the car. All of this we were able to integrate into Bazel, so all of those steps are now Bazel actions and can be cached, which is super awesome. MATLAB code generation can take forever. So this did not even speed up the CI system, but also the local development a lot. The remote caching server itself, we actually host multiple times for better load balancing, but this is, I guess, more like a technical detail. We are also using remote execution. However, we had a bit harder time to set this up correctly. The thing is, it requires way more hermetic tool chains, something where we screwed up a bit on at the beginning. However, we're currently using it for our long-running acceptance test, and there we are able to speed them up on average about 5 times compared to how fast we were before. We currently use BuildBarn for that, and we host it ourselves on our on-premise cloud. We know that some big cloud companies offer this as a service. However, we are not allowed to compile source code at the cloud of a company that also develops autonomous cars. So, sorry. But if you're into that kind of business, we think this is a really good business opportunity for you. Yeah. So how do we use it in the CI? Actually, as I said before, we put all the source code together into one workspace. We would have liked that workspace to be a mono repository, a true one single Git repository. But due to some legal constraints, we were not able to do that. Still, using Git submodules, we stitched together a workspace that feels like a remote repository all of the time, or most of the time. And since we're using Zool by OpenStack, which is a CI tool, we are also able to do this on the CI side, meaning the developer can change the code all over the workspace, even in different Git repositories, then pushes the code to the respective repositories. And Zool is then on the CI side, again, stitching all that together and checking it at once, and either merging all those changes in all those repositories at the same time or not. So we got this mono repository feeling, even though we are using multiple repositories. The CI strategy we are using is basically pretty primitive. It's build and test everything for every change, which is the most expensive thing you can do. But luckily, using Bazel, we are able to pull it off. On average, we are able to pull more than 90% out of the caches. So that's either the local action caches of our build nodes or the remote cache server. So even though we're using this very expensive test and strategy, the feedback times are reasonable. The cool thing about this test strategy is that you find defects as fast as possible. One last thing, we are now also able to do incremental builds on the CI. Technically, for sure, you could also do that with CMake, but we didn't trust CMake enough. Now we do.
OK, so I will tell you a bit about our journey with C++ toolchains. So as Axel mentioned, we started in the early phase with the small, hard things to tackle. And back then, the hardest thing you could tackle is getting your cross toolchain integrated into Bazel. So we started with the cross tool file, which was back then still written in protobuf and without any documentation, or at least not obvious to us. And while doing so, we learned a lot about compilers. So first thing is we're using partly Yocto to build some part of our base system and also our toolchain. Yocto has a smart way of packaging the toolchain in the SDK. It means you get an archive in a shell script, you download it, you execute it locally, it starts extracting itself, then it starts patching all the binaries in there to find the correct linker path. Which means you have some linker scripts in your tree which have an absolute path in there. So when you integrate this toolchain into Bazel without running all the scripts before, because that's something you certainly don't want to do, you end up in a situation where the linker always complains that it cannot find the files because it tries to link against your host files. We figured out basically that for the linker script, so to make the GNU linker happy, you need to have this equal sign all the time there, that it prefixes this tree with the sysroot. Otherwise, it won't. So you give your whole toolchain, you give it the sysroot, but it simply ignores it at this point in time. Next thing is, depending on how you call GCC, either with an absolute or a relative path, it creates dependency files in a different way. So sometimes in your dependency file, the tree to the files, to the header files, you depend on have an absolute path, sometimes they have a relative path. Bazel relies on a relative path. Due to the fact that we had to integrate the toolchains with some wrapper scripts, we figured out that we call GCC always with an absolute path. Therefore, afterwards, we got an absolute path in the dependency tree. And Bazel was complaining about, you haven't declared your dependency. But I did. Also, integrating non-GCC compilers. So you have seen before that we have also microcontrollers, that we have other systems where we get a toolchain which is certainly not based on GCC, not even close to it. And Bazel still back then made some assumptions on what you basically what your compiler needs to support. So that means we also had to write a lot of wrapper scripts to map or rewrite the calls from Bazel towards the compiler to make the compiler work with Bazel, or to reprocess certain outputs from the compiler that it fits to the requirements from Bazel. Luckily, meanwhile, we migrated to C++ toolchains, so things became much easier here. It gives us more flexibility in order to configure the toolchains for the certain compilers. A lot of wrapper scripts got obsolete, luckily, and we don't need to maintain them anymore. But there's still sometimes some surprises. One thing is that feature configs seem to be still inherited from the original config if they're not explicitly declared in your own configuration file. Next thing, our journey with Python toolchains. We heard previously already, I don't remember who it was, that Python is not integrated pretty well at the moment for certain parts. And we had the same experience, actually. Since our code base is mainly C++ and Python for all the tooling and tests, we also have, of course, certain dependencies on Python. Means we started with the upstream pip rules from the rules Python repository, which kind of shows up that they're unconditionally load all the dependencies you have declared there, even if you don't need them, which is okay-ish, I would say, as long as you don't have platform-specific wheels and you're developing on Linux and on Windows, because then it starts failing. So if you basically run your build on Windows and you have a platform wheel that's only compatible with Linux, it broke the workspace rules all the time. So that's also one, overall regarding the workspace rules, there's also one lessons that we learned. Be careful with your workspace rules. Actually, they're pretty dangerous at the moment since they are not hermetic. You can easily do stupid things in there and break your whole build. And we did a lot, very often. So please, do as little as possible in the workspace rules. We have meanwhile custom workspace rules for our wheel archives, which are unfortunately tightly coupled to another workspace rule which allows us to authenticate our dependency system. Thanks to Bazel, I think Bazel 1.2, where we get finally NetRC authentication again. We are now refactoring these rules, and we also try to make them open source afterwards. In our tree, we also had the coexistence of Python 2 and Python 3. Before we moved on with Python toolchains, this was a challenge for us because there was only one Python top. And we tried to make also this part as hermetic as possible, so we have our own way of having a hermetic Python integrated in the toolchain. Nevertheless, we had to use different Python tops in different configurations that we are building. That was really painful. After all, there were Python toolchains, so we migrated, or started to migrate, half a year ago. We figured out that we have meanwhile a bunch of wrong assumptions in our tree, which rely on Python top. 2 weeks ago, we finally managed to finish the migration to Python toolchains. So it took us still half a year. So now, one recommendation from our side basically is start migrating as soon as possible to hermetic Python. That makes your life much easier.
Yeah. So that simulation middleware I talked about before, it's ROS. Some of you might know it. It's open source. That stands for Robot Operating System. It's actually quite popular in robotics, not just academic, but also for production use. We use it a lot, especially for rapid prototyping of our algorithms. So where the code is not being deployed to the final hardware yet, but you already want to test it out on the road. So therefore, we put a lot of effort into making ROS work well with Bazel. And the video that can now start shows you how the current workflow looks like. I think it will just play in a loop, so maybe let's first watch it. Yeah, so I guess that looked kind of simple, but for us this was a huge step, because what you just saw is a developer modifying some source code, and then he's using a one-liner, well, a long one I have to admit, but still. He's using a one-liner to verify his changes in the simulator. And before using Bazel, that was really hard to do. You had to set up multiple terminals and run the correct commands in the correct order in different terminals, whatever, in order to verify that whatever you did works out well. Using Bazel, it's now one Bazel run command, and you can check whatever you did in the simulator. It doesn't stop there, though. If we go on to the next slide, you see one slide before that. Yeah. This is one of our cars, one of our test cars. There's a lot of stuff in the trunk, but especially that black box that is like a personal computer. And in that computer, you can insert your personal hard drive, which you can unplug from your workstation, go to the garage, put it in there. And then in the car, you can start up your personal Ubuntu and run the same command I showed you before, only with slightly changed parameters, hit the road, and test drive that thing. All with one command. So there, Bazel helped us a lot. I mean, for sure, this is for the rapid prototyping testing, where you just want to try it out if it kind of works. The actual testing before we give it to customers looks a lot different. I mean, for sure, then you also have all those runtime issues once you start using the final hardware and so on. But if we talk about like development speeds, Bazel and ROS, especially the combination of both, worked out really well for us.
Yeah, so as Axel mentioned, we developed certain rules for ROS. ROS has its own ecosystem. It comes with a bunch of tools, a bunch of generators. There are multiple versions of ROS, and they also have multiple build systems for ROS. So they have ROS build, then they had Catkin, and now in ROS 2 they have even something new again. So we figured out maybe it's also a good opportunity to bring Bazel into it, since they're obviously quite open for new build systems. So we developed rules for ROS, as you have seen on the architecture picture before. There are certain nodes. What is a node? A node is basically a system process that can either control sensors or actuators or does some math calculations. This node basically consumes, we have a rule for it. It's the ROS node rule. It consumes a binary that you have previously built either with CC binary or CC Python. It wraps it into a package for the ROS tooling. It generates some manifest files and prepares basically a workspace or a tree that can be consumed by the ROS tools. We also have rules for generating messages. So what is a message? How do the ROS nodes communicate to each other via messages, either via IPC or network-based messages, if you have a distributed cluster of ROS nodes. Messages are simple data structures, so you can more or less compare to protobuf, actually. The data structure of a message is described in a .message file or in a .service file. And we have a rule for it that consumes all these message files, runs the generators over them, and creates a library that you can afterwards link towards your binary for a ROS node. Then, to combine all the things together, we have a rule that's called ROS launch. It generates more or less a launch file. A launch file is basically an input file. So that Catkin knows exactly what kind of nodes it needs to start. It combines all the dependencies of your launch target into a tree, which is afterwards available in your run files. Because also the ROS tooling Catkin makes some assumptions on how your tree looks like. You cannot simply say, okay, I want to start this, give the individual paths, and it sorts it. No, it assumes that there is a structure available, and then it follows the structure and tries to find, in a smart way, all the nodes it should start. So we have here the ROS launch target that you can afterwards also call with Bazel run or Bazel test, as we have seen in the video before. Yay. So unfortunately, we haven't managed yet to make the rules open source. We are working on that. We had our one target to make it open source until today. We failed. But we will continue working on it. So we figured out that we have some certain BMW infrastructure specific assumptions in these rules that we first need to sort out before we can make the rules open source. They will be available on our GitHub page. And we would invite everyone to contribute here and also to exchange some ideas how we can improve the rules for ROS.
Yeah, that brings us pretty much to the last point. When can you buy the first Bazel car? That will be in 2021, so not too far away. Then we will release the BMW Vision i Next. And also all BMWs which launch after that vehicle will have been built with Bazel. Or at least their driver assistance system will have been built with Bazel. It's not just that, though. Toolchains are known to propagate a lot in our industry. So my personal expectation is that in a couple of years, other OEMs and suppliers will follow. We already see that. So there will be more Bazel cars on the road soon. That's it. Thanks for having us. And we're looking forward for your questions.
Thanks, Axel and Patrick. I am very much looking forward to riding in the first Bazel car. So, it sounds great. As per normal, have questions up here in the middle. Give people a chance to go from there. Why don't we start up top first this time, and we'll go from there. We got about less than 15 minutes, 9 minutes for questions.
David at National Instruments. You mentioned that you got 5 to 6 engineers to prototype this and kick it off. How many are continuing maintenance on your Bazel-based work?
Why not?
Well, we by now got several teams which more or less work in our release and CI pipelines, and those people who have been in this initial Bazel team are now distributed across those teams. So there's not a single Bazel team anymore, as there used to be. It's now different purposes teams, but basically the knowledge spread as the people spread.
And how would you compare that to what you had before?
You mean how many people maintained the CI system before to?
Versus like with CMake and the other tools that you replaced?
It's kind of hard to tell in our case because it's not just the build system that grow, but also the manpower in general. Well,
I would say that there are two things. So one thing is we are still not completely done with it, right? So we still have a lot of things to tackle, to stabilize, to improve, to speed up, because also Bazel is evolving, luckily. We also need to keep up with newer versions of Bazel. So that means we need now still more people than we would need if we have a well-established tool chain that we just need to maintain and see that nothing breaks, right? So all in all, we have still 15 to 20 people with a strong focus on this Bazel environment.
Yeah, that sounds about right. And I think also one thing that changed really in our organization is that now the build tool is no longer seen as something as a must-have where you try to spend as few as possible on it, but rather as an advantage when it comes to development speed. So by now we luckily do have pretty good chances if we ask for more manpower if it comes to improving our build times.
Thank you.
So, hi there, I'm Ed Schouten and I'm the author of Build Barn. I was wondering, what do you guys dislike about Build Barn most?
Actually, a pretty good question. I would really like to get in contact with you. So maybe we can meet later again. Just for now, we like it a lot. There are different alternatives, and this is the best one, so we picked that one. I think current biggest issue, I think the monitor is not working anymore, right? After the Bazel 1.0 update, the results monitor.
Oh, yeah.
Yeah.
The build event service, yeah.
Yeah. Yeah, but please, let's have a talk afterwards. Yeah.
Hi, I'm Michael. I work at Tesla, so we're obviously very interested in your work here. I was hoping you could talk a little bit about how incrementality works with respect to your simulations, because naively I would sort of expect any change anywhere in the system to invalidate the simulator, which is maybe running everything as a black box. So if you could talk about how that works and if caching has helped you at all for potentially long-running simulations.
Yeah. No, you definitely hit a pain point there. As you said, the simulation, or we call it the acceptance test, are supposed to test as much as possible of your software stack, right? So any potential change would just invalidate almost all of those previous test results and therefore your cached results. That's why those tests were the first one we put onto the remote execution side of things, because they could not really be tackled with caching so much, and that's why we used remote execution here.
Thanks.
Yeah.
Hi there. I'm Mark from Lyft. My question is, yes. I want to know how you maintain consistency in your environments between like developer workstations, your CI, and like running on the car.
So before Bazel, we had basically a list of Python packages and Debian packages, which were then installed using the usual tools, either on your CI as a Docker container or on your local development machine. But then you ran really often into those works on my machine, but not on your machine issues. What we do now is basically we still have those Debian packages and pip packages being installed, but we're reducing them one by one and moving them to the Bazel workspace. We have only a few left, so by now we got it pretty much nailed down, and this gives you as much as consistency as at least we did not have before.
Okay. Do you have like problems with, say, like one of those packages changing in workspace, and then like your entire workspace is, say, invalidated, and then you have to re-download everything?
Yeah, for sure.
Okay. All right.
Yeah.
All right. Thanks.
Yeah.
Austin Chu, Blue River. How have you guys dealt with toolchain qualification for ISO 26262?
That's your topic.
Sorry, can you ask?
Toolchain qualification.
Toolchain qualification is part of ISO 26262, and Bazel becomes part of your tooling, so
Correct.
you need to start to address it at some level.
Correct. Exactly. So we looked at it for the ISO 26262. Basically, we what you typically do is you analyze the impact of this tool to the overall outcome of it and how likely it will happen. So we looked not only on the specific tool, because that is what most people often do. They look at a specific tool and how can this impact, but we looked at the whole tool chain basically, and how does this tool behave in the whole tool chain. And back then we figured out that we certainly need not only to qualify Bazel, but also to look into the whole tree and see what else could find problems caused by Bazel. Means we have certain mitigation tests all over the place in the end to just ensure that Bazel as orchestration does still the right thing. Still losing my micro? No, it's there again. Okay. So it's a big effort to get it done. Because you need to know what you're doing still, and you need to know what afterwards is happening with your artifacts, that you can basically derive from that what kind of mitigations you have to put in place.
Thank you.
Hello, my name is Anthony. I work in General Atomics. My team works on autonomous drones. And in GA, or in aerospace and autonomous industries in general, we have to make sure our code follows MISRA standards. And I was wondering, how did your team use Bazel to make sure your C and C++ code is MISRA compliant?
Oh, yeah. Again, one of our pain points, of course. So we have certain MISRA checkers and also code quality checkers, static code analysis, all this in place. But it's a bit tricky to get the inputs in the right format for your tools, basically. So how did we do that with Bazel? Bazel offers various ways to extract or query basically your files that you use for build, and then you can set up some packages that you just feed outside the Bazel build into these code quality checkers. So it's actually not triggered by Bazel itself, but it's still done outside.
Hi, John Field, Google. I'm just curious, and apologies if you mentioned this, do you use Build Barn for development builds as well as CI, or just CI only?
It's currently only CI, but we are planning to roll it out for developers also, yeah.
Great, thanks.
Hi, I'm Chuan from Neuro. So you mentioned you are making all the build hermetic, like including all the third-party dependency, like and find there are a lot of open source dependency, or you have to build right. Are you writing like a manual route, like manually write all the rules to build all the open source project, or how you track them dependencies?
For the open source tools, you mean basically from the packages for open source, like Debian files,
yeah, more
real
like
files, or basically like what we have heard before, the workspace files that you can inherit from other projects?
It's not just workspace, like for example, OpenCV or many other things that doesn't have an existing Bazel rule for them. Like how do you compile them and as part of hermetic build.
As part of that, we Bazelfied several open source components as well. Luckily, in our environment, due to the fact that we have to build software for a safety car, it's not that many. So either we consume them as a binary, pre-built already, like the platform wheels, or we Bazelfy them and put them into our third-party tree.
Good, thank you.
Thanks.
Okay, that's perfect, right on time. Thanks so much, Axel and Patrick.
Thank you.